Hello! In this video, I want to talk about how to calculate probabilities that involve the key phrase at least one. Okay? And I'm still in the world where I'm going to be calculating my probability using combinations. Alright? So, alright, let's go ahead and read through this example. So you randomly select 5 cards from a standard deck. Okay? So you got 5 cards, 1, 2, 3, 4, 5. Okay, you randomly select 5 cards. If you select at least one heart, okay, so there's our key phrase, at least one. So one of them has got to be a heart. Right? It could be one of them. It could have been 2 cards that are heart, 3 cards that are heart, 4 cards that are heart, or all 5 of them are hearts. If you get at least one heart, then you win the game. So find the probability that you win. Okay? So one way that you could think about this, let me write this down. So the probability that you get at least one heart, right? We could think about this as being the probability that you get one heart, right? That'll be at least one, right? Or you could have gotten 2 hearts. So if we add that to the probability of getting 2 hearts, or 3, you'd still win, right? 4, you'd still win. So 4 hearts. And you could have gotten all 5 hearts, right? Any of these options, you would win the game. So if you add up all those different possibilities, then that'll give you the probability of at least one heart, right? They're all independent events, so you can just straight up add them. All right. Yeah, that's a lot to calculate because you got to calculate all of these probabilities, and that's time consuming. So there's actually an easier way that we could go about this problem. All right, so we're going to use complements, the idea of a complement to solve this problem. So let me talk about complements. First, let's start with the idea that the probability that you win, if I add that to the probability that you don't win, okay, those are the only 2 options. Either you win or you don't win, right? So if I add these 2 probabilities together, I should get 1, right? It's a 100% chance that I win or I don't win, okay? So I could rewrite this using algebra. This is 1 minus the probability that I don't win. Okay, so the probability that I win equals 1 minus the probability I don't win, right? This is a complement, right? So the probability of an event equals 1 minus the probability of its complement, all right? So now let's think about what's the complement of at least one heart. One heart. Okay, so the probability that I get at least one heart, that's the same thing as probability of winning, equals the probability that I don't win. So how do I not win? How do I not win? I get 0 hearts, right? I have 5 cards and none of them are a heart. That means I don't win, right? So the probability of getting 0 hearts. All right, so the probability I get at least one heart is 1 minus the probability of getting 0 hearts. All right, so see, this is one probability that I have to calculate versus having to calculate 1, 2, 3, 4, 5. This is a lot easier, right? That's the idea. Using complements to solve problems that involve at least one is always going to be a lot easier than calculating this complete sum. Okay, so this is the preferred way to do this problem. You'll get the same answer either way. It's just this way, you'll take a lot longer. Okay, so now I only have to calculate one probability. Let's think about that. The probability of getting 0 hearts. So this would be the number of ways I can select 5 cards and not get a heart. So maybe I got 2 diamonds, 3 spades, 2 spades, 3 clubs, 1 club, 4 diamonds, whatever it is. There's a ton of different ways that I could have selected 5 cards and not get a heart, right? There's a ton of ways I could have done that. We need to calculate that, the number of ways that I could have done that. And we'll need to divide that by the total number of ways I can select 5 cards. Okay, so the total number of ways I can select 5 cards, including the ways that have the hearts, right? All right, so let's think about this. Number of ways I can select 5 cards and not get a heart. First, let's think about how many cards are hearts and how many cards are not hearts. I have a deck of 52. There are 4 different types of cards. We have the hearts, we have the spades, we have the diamonds, and we have the clubs. Okay, so that means there are 13 of each type. Okay, one of them would be a heart, and the other 3 types are not hearts. So that means there are 39 cards that are not hearts. Okay, so I have 39 cards, and I want to choose 5 of those 39. That's the number of ways that I can select 5 cards and not get a heart. Now, order doesn't matter. All it matters is what is in my hand. Right? It doesn't matter what order I picked it up, so that's a combination, not a permutation. Okay, so then I would want to divide that by the number of ways I can select 5 cards. So there are 52 cards in the deck, and I'm selecting 5 of them. All right, so there we go. So 1 minus the probability of getting 0 hearts, and this is, we have to solve this to find the probability of getting 0 hearts. So let me go ahead and write this out. Now let's go ahead and use our formula for combinations. N choose k, n factorial, k factorial, n minus k factorial. All right, so 39 factorial divided by 5 factorial. 39 minus 5 is 34. Okay, so now I'm going to go ahead and divide that by 52 factorial divided by 5 factorial, and let's see, what do we have here? We have 52 minus 5, which would be 47. All right, so now I just need to simplify this mess. First, the 5 factorials are in both denominators, so they will cancel with each other, so I can go ahead and cancel those out. 39 factorial, I will have 39, 38, 7, 6, 5, and then I'm going to have 34. I'm going to leave that as a factorial because that will cancel with its denominator, 34 factorial. Let me scroll down a little more. All of this divided by 52. I'll write it to 50, 49, 48. I'm going to leave the 47 because that will cancel with this 47 down here. Okay, so let's do our cancellations. This guy cancels with that. This guy cancels with that. Okay, so I have this equals 1 minus 39, 38, 37, 36, 35, all divided by 52, 51, 50, 49, and 48. All right, this point you pull out your calculator. So this is 1 minus 0.2215. All right, 1 minus 0.2215 is 0.7785. All right, so the probability that I get at least 1 heart if I select 5 cards is 0.7785. My chances of winning this game are pretty good.